For a brief moment in October, NVIDIA was the first company ever to reach a $5 trillion valuation, thanks to its original gaming engine, the GPU, becoming king of AI chips. So what exactly optimizes a chip for AI?
A GPU, in this case, was really purpose-built to deliver parallel programming. Because when you think about rendering an image or a scene, you need to calculate all those pixels at once. And so AI really lends itself to taking advantage of that capability.
To understand how GPUs became synonymous with AI, let's go back to 2012, to what many consider AI's big bang moment, AlexNet. It was a new, incredibly accurate neural network that obliterated the competition during a prominent image recognition contest. Turns out, the same parallel processing used by NVIDIA GPUs to render lifelike graphics is also great for training neural networks, where a computer learns from data rather than relying on a programmer's code.
The researchers took a GPU and said, I'm going to hack it to get it to expose the parallel computation capabilities to unlock that performance for the deep learning use case.
While AI workloads are usually accelerated on a GPU or custom ASIC, it still often needs a host central processing unit, CPU, like the Grace in NVIDIA's Grace Blackwell server rack system. But while a CPU has a small number of powerful cores running sequential general-purpose tasks, GPUs have thousands of smaller cores, more narrowly focused on parallel math like matrix multiplication, used to process multidimensional data structures known as tensors. This ability to perform many operations simultaneously makes GPUs ideal for the two main phases of AI computation, training and inference. Training is teaching the AI model to learn from patterns in large amounts of data, while inference uses the AI to make decisions based on new information, the way AI shows up in everyday applications.
Whether it's the way you buy your coffee on your Starbucks app, or how you interact with Salesforce for work, or speaking to us through our earpods, that is being done through inference.
NVIDIA sells its GPUs directly to AI companies, like in a recent deal to sell at least $4 million to OpenAI, and to foreign governments, including South Korea, Saudi Arabia, and the UK. It also sells GPUs to cloud providers like Amazon, Microsoft, and Google, who go on to rent them out by the hour, minute, or second. NVIDIA also has a GPU rental program. Today, systems that can handle AI workloads are in such high demand, one of these 72 Blackwell server racks sells for around $3 million. And NVIDIA told us it's shipping 1,000 each week.
And for NVIDIA, they're looking to sell the entire system, not just the chip, because when you think at that system level, you get more efficiencies in terms of speed and power and performance.
Of course, NVIDIA isn't the only one making rack-scale GPU systems optimized for AI. Its top competitor, Advanced Micro Devices, AMD, has seen major gains with its Instinct GPU line, and major commitments from OpenAI and Oracle. A big difference in AMD GPUs is that they use a largely open-source software ecosystem, while NVIDIA GPUs are tightly optimized around CUDA, NVIDIA's proprietary software platform. NVIDIA says its next-generation Rubin GPU will be in full production next year.
This is just an incredibly beautiful computer.